Welcome to the DIY Honda Garage channel. This presentation addresses the diagnostic troubleshooting process for DTC P0717, which pertains to the input or turbine speed sensor A circuit no signal issue found in Honda Accord models manufactured between 2012 and 2017. The error specifically indicates a problem within the electrical circuit connected to the transmission's turbine speed sensor, an essential component for proper transmission operation. The turbine speed sensor measures the rotational speed of the torque converter's turbine, which is vital for proper transmission shifting and control. This sensor is located in the transmission area, typically mounted near the torque converter inside the transmission housing. The error code suggests an electrical circuit malfunction, which could be caused by issues such as open circuits, shorts, or poor connections. But it cannot be caused by mechanical problems within the transmission itself. Proper diagnosis involves reviewing freeze frame data, onboard snapshots, and following a systematic troubleshooting approach to identify the faulty circuit or component. To conclude, troubleshooting DTC P0717 requires a systematic approach, starting with verification of codes and confirming system status through test drives. Step-by-step voltage checks, wiring inspections, and circuit tests ensure that each potential cause is investigated thoroughly. Common issues include open circuits, shorts, faulty sensors, or outdated software, so addressing each logically is necessary. Replacing malfunctioning sensors, fixing wiring issues, or updating the PCM helps restore proper communication and transmission operation. Finally, verifying the repair with a repeated drive cycle and monitoring the diagnostics ensures the fault no longer exists and the vehicle functions correctly. Following these key points guarantees a comprehensive and effective repair process. The initial step involves verifying the presence of the DTC P0717 and recording all freeze frame data for future reference. Ensuring the vehicle is in the correct ignition mode, either on or engine running, is crucial before clearing the DTC with the Honda Diagnostic System, or HDS tool. Once cleared, the vehicle must be properly supported, either on a lift or with wheel blocks, so the front wheels can rotate freely without interference. Starting the engine and disabling the vehicle's stability assist system ensures the system's operation isn't affecting the sensor readings. A test drive exceeding 19 miles per hour for at least 30 seconds is necessary because the sensor detection and signal processing occur at this speed range. Once the drive cycle completes, recheck for any active or pending DTCs in the HDS. A duplicate code reinforces the presence of an ongoing issue requiring further diagnosis. In this step, the technician needs to verify whether the DTC P0716 appears alongside P0717, confirming a duplicated failure, which suggests a persistent circuit issue. If P0716 is present, it indicates similar circuit problems affecting both sensors or related circuits, prompting the technician to proceed to further testing. If P0716 does not appear, the problem may be intermittent, so it's essential to check for poor connections or loose terminals between the powertrain control module, PCM, and the turbine speed sensor. Ensuring stable physical connections and sound terminal contacts can mitigate false readings and false DTCs. System duplication detection helps determine whether the electrical issue is persistent and requires targeted repairs in wiring or connectors. The third step involves verifying the power supply voltage to the turbine speed sensor, specifically the VCC2 line, which provides the necessary operating voltage. Turning off the ignition, Then disconnecting the sensor connector isolates the circuit for accurate measurement. Using the Honda diagnostic tool, the technician measures voltage between test point 1, connected to the VCC2 terminal, and ground. The ideal reading should be approximately 5 volts, indicating the supply line is functioning correctly. If the voltage is not present or significantly different, an open in the VCC2 wire or a faulty power supply circuit is suspected. Repairing any open circuits or wiring issues at this stage restores proper sensor function for subsequent testing. This step focuses on confirming the sensor's operational voltage. Disconnecting the sensor connector allows for measuring the voltage directly from the sensor terminals. The measured voltage between test point 1, which connects to the sensor's signal or power wire, and the common ground should be around 5 volts. If this voltage is correct, but the error persists, replacing the turbine speed sensor is necessary, as it may be faulty or sending inaccurate signals. Conversely, if the voltage is insufficient or absent, an open circuit or wiring fault in the SG2 wire, which links the sensor to the PCM, should be repaired. This ensures the sensor has the proper operating environment needed for accurate torque converter speed monitoring. Here, the focus shifts to locating potential short circuits in the NT line, which supplies power to the sensor. Turning off the ignition, then jumping the SCS line using the Honda Diagnostic System's jumper function, HDS, isolates and tests the circuit's integrity. Disconnecting the PCM connector ensures no interference and verifies the wire's condition separately. A continuity check between test points must be performed. If continuity exists between the sensor line and ground, the wire is shorted and requires repair. Identifying and repairing shorted wires prevent false signals or sensor failures. This step is vital to rule out wiring issues that could cause the no-signal error code. The sixth step involves comprehensive testing of the wire continuity between the turbine speed sensor and the PCM connector. Ensuring unobstructed, correct continuity confirms that signals can pass freely without interruption. Additionally, the PCM software version should be checked. Outdated software may cause misinterpretation of sensor signals, so updating the PCM may resolve the issue. If problems persist despite wiring integrity, substituting a known good PCM can help identify whether the vehicle's original PCM is faulty. This test ensures that the communication pathway between the sensor and control unit is fully operational and compatible. The final step in the troubleshooting process verifies whether the repairs rectified the issue. Reconnecting all disconnected connectors ensures the circuit is complete. Exiting the system check mode and clearing the DTC using the HDS prepares the vehicle for a fresh diagnostic cycle. The test drive should conform to the specified speed and duration to ensure the sensor is active and signals are transmitted properly. Monitoring the onboard diagnostic system for the status of P0717 indicates the success of the repair. A past reading confirms that the circuit no longer exhibits faults. If the DTC passes, the initial problem is resolved. Otherwise, further diagnosis may be required to find hidden issues. Preventive measures involve routine inspection of the wiring harness and connectors associated with the turbine speed sensor circuit to prevent corrosion, damage, or looseness. Maintaining tight connections ensures reliable signals and reduces the likelihood of false DTCs. Regular PCM software updates improve vehicle communication stability and fix known issues, which can prevent sensor-related problems from arising. After any repair, conducting a thorough test drive confirms system operation in normal conditions. Adopting these preventive practices helps maintain the health of the transmission sensor circuits and avoids future diagnostic trouble codes. Please like and subscribe to the channel. See you next time.